So today we're going to look at lesson 1-4, solving equations, and we're going to start out simple. I'm just doing a few problems because this is a review from Algebra 1-2. And so in this particular example here, we have x plus 4 equals negative 12. So there's your left and right side. X is the star of our show, so I'm going to circle it. And then that means I want to get rid of a plus 4. So the opposite of adding 4 is subtracting 4. And so my 4's are going to cancel, and I'm left with an x on the left, and a negative 12 plus, because technically I'm adding that negative 4 to it, gives you a negative 16. And so here's our answer. And you can check your answers to make sure that you have the correct answer. So I'm going to do the check over here. I got a new stylus, but it's still not perfect. It's better than my other one. I'll have to get me a different one. But for my check, I'm going to replace my x with the value that I came up with for an answer. So instead of x, I'm putting in that negative 16. And so on this side, negative 16 plus 4, I'm just going to add those together, and I get a negative 12 that does indeed equal the right side, which is negative 12. So it checks, and x equals negative 6 is a good solution. So let's move on to example 2. So in example 2, we have a little bit more difficulty. So again, here is my right and left sides. I'm going to draw that line straight down because whatever you do to one side, you must do to the other. But we're going to clean up both sides first. So anytime you have something to distribute, you're going to distribute that first. So here's my equals. 3 times y is 3y. 3 times negative 3 is a negative 9. Be careful of your signs. I'm not going to do anything to the left side. There's no like terms to collect, nothing to do. So now I have this side's cleaned up, this side's cleaned up, but I do have a variable on both sides. Remember, the variables are the star of your show. And so you have to choose, do you want to move the 6y over here or the 3y over here? I tend to move the smaller over to the other side. So because 3y is smaller, I'm going to add its opposite. So the opposite is negative 3y and negative 3y. So our y's cancel on the right. And on the left, we have negative 27 plus 6y minus 3y is 3y equals, and then we have a negative 9 on the right. So the star of our show is the variable term, in this case 3y. To get rid of a minus 27, we are going to add 27 to both sides. And so I have 3y equals a positive 27 and a negative 9. We're going to subtract and keep the sign of the larger, and so we get a positive 18. And then focusing on the variable term, to undo 3y, we divide both sides by 3. So I have an answer of y equals positive 6. So let's check this solution. So here's my check. Okay, so I've got, don't have very much room here, so I'm going to try to squeeze it in here. Negative, whoops, that's a 27. Plus 6, instead of y, I'm going to put in our value, equals 3 times, and then I have a minus 3 here. I'm going to squeeze that in. So then in place of our y's, I'm going to put in a 6 here and a 6 here. So on the left-hand side, I have negative 27. 6 times 6 is 36. And then on the right side, I have 3 times 6 minus 3 is 3. And then on the left side, negative 27 plus 36 is indeed 9. And then on the right side, 3 times 3 is 9. So the left side does equal the right side, so our solution is good. For example 3, we have a word problem, and for our word problems, we are going to typically do this 4-step plan. So I'm going to kind of squeeze it in here off to the side, but notice Let's go ahead and read the problem. It says, flower carpets incorporate hundreds of thousands of brightly colored flowers, as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from the Grand Palace in Brussels, Belgium, has a perimeter of 200 meters. So that's some important information. And then what are the dimensions of the flower carpet? So you need to look at the picture. As you notice here in the picture, they're calling this dimension x. And notice here, this dimension is 3x. So oftentimes you get some of your information from the picture. So one of the key phrases that I noticed that they used here was a perimeter of. So immediately my brain goes to what is the perimeter formula, and this happens to be right here, this flower carpet happens to be a rectangle. So the perimeter formula of a rectangle is twice the width plus twice the length. And so here I'm going to define my variables. So I'm going to let the width equal this distance here. So it's going to be x. And my length is going to equal this distance here, that 3x. And then the one thing that we also have to add in here is that we have a perimeter of 200 meters. So that's important, and you kind of see that here too. I just wrote that same thing but made it bigger. So that 200 is going to be our P. So P is equal to 200. So with the equation that we came up with, because I mentioned the word perimeter, I'm going to replace the values that we have. So instead of P, we have 200, and then equals 2 parentheses, and instead of width, we're going to put in X, and then plus 2 parentheses, and instead of L, we're going to put in its value, 3x. So now I have 200 equals 2 times x is 2x, and 2 times 3x is 6x. So on the right-hand side, I can collect like terms right here. So I end up with 200 equaling 2x plus 6x is 8x. And then I'm going to divide both sides by 8. And so I get an x value is equal to, let's see, 8 goes into 20 twice, 4 left over, so it'd be 25. Does that answer the question? So the question says, what are the dimensions of the flower carpet? Well, remember, x is the width. So we still have to find 3x. So that means 3x is going to be 3 times 25, which is 75. So therefore, dot, 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 for that word therefore, the dimensions are 25, and we have to have units of measure. So note that the units of measure that they gave in the problem was meters. So that's the units of measure here, and so I can use those here. So 25 meters by 75 meters. Okay? All right, example 4, we have 2 parts to it. So this is example 4a, and the question says, is the equation always, sometimes, or never true? Well, let's see. Let's go ahead and solve the equation for x. So on the left side, I have some like terms that I can combine. So I'm going to combine the 7x and the negative 4x, and that's going to give me a positive 3x, and then plus that 6, and then equals. And then on the right side, I've got 12 and a negative 8 that I can combine. And so 12 minus 8 is 4, and then bring down the 3x. So I've simplified both sides, and so now I need to get the x terms, because they are the star of the show, on one side or the other. I generally like to move the smaller term. These happen to be the same size, or the same term, so look what happens. If I decide to move this x by adding its opposite, a negative 3x, to both sides, notice that the variable terms drop out. The first thing you should check for is, did I make any errors? And in this case, no, you certainly did not. And you're left with 6 on the left equals and 4 on the right. So you have this statement here that you have to determine, is that true or false? Well, 6 does not equal 4, so this is false. And if it's false, that means the solution is no solution. Since the answer is no solution, that means it is never true. So the actual answer to this question is never. Your work is your support for why you said it is never true. All right, let's look at example 4b. So in example 4b, I want you to go ahead and do this on your own. Distribute, collect like terms on each side, get the variable on each side, and then come up with an answer. And based upon that answer, decide, is that equation always, sometimes, or never true? Go ahead and pause the video, do your work, and then restart it. All right, so hopefully you've already done your work. So I'm going to go ahead and distribute here. So I have a 2x plus 3 times x is 3x. 3 times negative 4 is negative 12. And then if I distribute here, 2 times 2x is 4x. 2 times negative 6 is negative 12. And then don't forget about your plus x. So then on the left side, I've got a 2x and a 3x that I can combine, and that makes 5x minus the 12 equals. And on the right, I have a 4x and an x that I can combine. 4x plus x is 5x, and then bring down your minus 12. I need you at this point to keep finishing the problem. You haven't gotten the x's on one side by themselves. So again, you've got the 5x's are both the same. So if you try to move one of them, you're going to end up with both of them canceling out. But please write down what you have left over. On the left, I have negative 12, and on the right, I have negative 12. So hopefully you pause to determine, is this true or false? Well, negative 12 does equal negative 12, so that is true. And so the solution to this would be all real numbers. So if any number you could possibly think of will make this equation true, then the answer is always true. Because no matter what answer you have, it's always going to work. Well, what is sometimes? Sometimes is if you get one value for x, x equals 2. So the equation is sometimes true as long as x is 2. If x is any other value other than 2, it's not going to be true. Never true again means that no value of x will ever make it true. So that was what we did in 4a. And then always is any value you can think of for x would make it true, as you see here. All right, last problem. So on this last problem, number 5, this is called a literal equation. And you have an equation right here that has several variables in it. It's got a c and an f. And your goal is to solve the equation for f. Right now it's solved for c. But we want it to be f equals. So f currently is in jail inside these parentheses. So we're going to have to break it out of jail. And we're not going to get an actual answer for f. We're just going to get a different equation when we solve literal equations for a different variable. So the first thing I want to do, I could distribute the 5/9 into this, and that's a possibility, but I know for a fact that 9 does not divide into 32. I'm going to get this ugly fraction. So here's a suggestion that you might want to use if you're in a situation like this. Since the 5/9 is in front of the fraction, I can multiply this side by the reciprocal 9/5. I'm going to multiply those together. What I do to one side, I must do to the other side. So the other side would be multiplied by 9 over 5 as well. Now, the 9 cancels here with that 9, and the 5s cancel here with that 5, which means that sorry, lunch is over. Which means that we now have a 1 in front of the parentheses to distribute. You don't multiply this to everything inside. You just multiply it here, and then these are going to cancel. You're left with that 1. And so now I have on the right side of my equals in f minus 32, I'm dropping the parentheses because there's a 1 in front. And then on the left-hand side, I have a 9/5 c, or you can write 9c over 5. It's up to you. And then to solve for f, because remember f is the star of the show, I'm going to add 32. Since c, this is a c term and this is just a constant term, they're not like terms. They don't have anything in common. So we cannot really combine them. I'm going to write it as 9/5 c plus 32 is equal to f. And if you don't like f on the right side, then flip-flop it. So it reads f equals 9/5 c plus 32. They are both the same. All right, if you have any questions, don't hesitate to ask me for help.